This is page 3 of transformations. First thing that it asks us is, what are the 3 kinds of transformations we will study in this chapter? And the 3 kinds are translations, stretches, and reflections. Just to remind you of what each of those are, let me draw examples. So a translation is if you have a original drawing and it moves sideways or up and down to a new position. Okay, so that's a translation. A stretch would be you have a drawing which becomes narrower, or maybe it becomes wider, or maybe it becomes taller. Reflections would be the drawing gets reflected over an axis, kind of like that, or maybe up and down. Think back to the transformations investigation. So now let's talk about the investigation. Remember, in the investigation we had this very complex function. Basically, the key parts to this function are the A, B, and C, and D parameters, which do the translations and stretches in this function. So let's just circle those first. And then we can compare it to the standard form where we have an original function, f, and the original function f, it has the a, b, c, d operating on it. And do you notice that inside the parentheses of the f, the input of the f, we have the b and the c along with the x, of course. And then on the outside, we have the a and the d. Okay, so if you remember from the investigation, the outside 2 parameters, A and D, do the vertical changes, and the inside parameters, B and C, do the horizontal changes. If you remember, the multiplying factors, A and B, they do the stretching and the compressing. And the adding or subtracting parameters, C and D, those do the translations. Okay, so since we know that A and D are the vertical, and we know that A does the stretching and D does the translating, we know exactly what those two do. Same thing with the inside. B is multiplying and it's on the inside, so that means it's doing the horizontal compression and stretching. And the C is doing the horizontal translation, right? So inside is horizontal, outside is vertical, and addition subtraction is translation, and multiplication division is stretching, compressing. Okay, so let's fill this in. So A would be vertical stretch, B would be horizontal stretch, and C would be it's inside, so it's horizontal, and it's adding, subtracting, so it's a translation. And D is outside, so it would be a vertical translation. Okay, all right, let's move on. Okay, so in this example, we are doing algebraic transformation. So we start out with the original function, which in this case is something squared. One thing that's confusing about these substitutions is the x here is signifying that we are going to put something in its place. So if you just think, instead of x, if you think of it as like an empty box, it's basically saying empty box squared, and if you put something in the box, you're going to replace that box with the something, okay? And always put parentheses around the something. So in this case, we're going to be working with the function empty box squared, and we're going to substitute in the inside of the parentheses each time. And the putting in the outside things is more simple because you don't need to do anything with the function. You just write it on the outside. So let's start out with doing these two. In A, we're going to substitute in 2x every time we see the box. So it'll be 2x in the box squared. And you can see that's what you end up with. And if you simplify it, it'll become 4x squared because the 2 is in the parentheses and gets squared also. Okay? Now, when we have f of x over 3 in the parentheses, that means we're going to put x over 3 in the box squared with parentheses around it. So it would end up simplifying to be x over 3 in parentheses squared, which would be x squared, the top squared, and the bottom squared. 3 squared is 9, right? And then if we're going to have 2f of x plus 1, we're just going to put x inside. So the function itself, box squared, just becomes x squared, the original. And then we're going to multiply that by 2, and we're going to add 1 to it. And then if we have x plus 3, that would be x plus 3 inside the box squared. And then we're going to subtract 4 on the outside. So that was a pretty easy one. We had a horizontal component and a vertical component, right? And then we just put x plus 3 substituting in for the box, which was originally x, okay? So the confusing thing is we're substituting x with x plus 3, and the x here is basically just saying, oh, this is like a blank spot that you're going to substitute into with your contents, which sometimes has an x in it and sometimes it's just a number. Okay, when we simplify this, we just do FOIL, and then we subtract 4, and then we simplify. Okay, so this next example is kind of like so easy that it might be difficult, because do you notice that the function is just x itself? So basically it's saying whatever you're substituting in, you don't need to do anything. You don't need to square it or anything. You just write it down. Okay, so let's put 2x into the box, and then we're just done, right? Because we don't do anything to it. So the function here is just 2x. In this one here, basically it's just like put the contents of the parentheses into the box and add 2. So it would be x plus 2, and that's it. You're done. For this one here, we're just putting x into the box, so it would be just x, and then we multiply it by times 1/2. Also easy. This one here, the f of x is just the box, and then we substitute in the inside of the box, which is x, so it's just 2x plus 3, 2x plus 3, right? Okay, so that one was so easy that it might actually confuse you. So let's do a slightly more difficult one on page 4. Okay, so now we're doing something cubed. Okay, so whatever is inside the parentheses, we're going to put it inside the box, and whatever's outside the f of x function, we just operate on the function something cubed, right? So in this case, we just have 4x inside the box, so we just put 4x inside the box, and that's cubed. So it'd be 4x cubed. That would be 4 cubed x cubed, which is equal to I think it's like 64 x cubed. Okay, and then we have 1/2 f of 2x. 2x is going to go inside the box, and then it's cubed, and then we multiply that function times 1/2. So if we simplify it, it would be 1/2 2 cubed x cubed, which would be 1/2 times 8 times x cubed, which is 4x cubed. Okay, so now we're going to do x plus 1 in the parentheses. So we're going to put x plus 1 into the box. So that would be x plus 1 in parentheses in the box cubed. And if we simplify that, we'll just put x plus 1 quantity cubed. I don't think expanding this with binomial expansion is going to make this easier, so we're not going to do that. In the next one, we got the same thing on the inside, so it would just be x plus 1 cubed, but then we also multiply it times 2 on the outside and subtract 3. And if you wanted to, you could do a binomial expansion of that, but I don't think that really makes it easier, simpler. It doesn't ask us to expand, so. Now, this one here, some people find difficult because the x is in exponent, and it's very small. So we just replace it with a small little box, and we're going to put whatever the contents of the parentheses are into that small little box. So we're going to have 2 to the 2x. If you could put in parentheses if you want to, it'd be equal to 2 to the 2x. In this one here, we're going to have 2 to the negative x in the box plus 1. So if we simplify that, it'll just be 2 to the negative x plus 1. Here we got x minus 2 in the box, so we'll put 2 to the x minus 2, and then we have plus 3 on the outside. So we could simplify that as 2 to the x minus 2. Oops. 2 to the x minus 2 plus 3. And then the last one would be 2 to the x, because inside the parentheses is just x, plus 3. So that'd be 2 times 2 to the x plus 3. If you want to, you can combine the 2 on the outside with 2 on the inside, making it 2 to the x plus 1, but I don't think that really makes it any easier, so you can just leave it like this. And number 5. So now we got another confusing one. We have 1 over something. So basically all we need to do is put the contents of the parentheses in the denominator of this fraction. So we're going to put, instead of x, we're going to put negative 1 over x. So it would be negative x. We're going to put negative x in the bottom, and then we could simplify that to negative 1 over x. Here we're going to put 1/2 x in the box. And the hardest part of this is just the fraction math, right? 1 over 1/2 is actually equal to 2 because you do 1 divided by 1/2. When you divide by a fraction, you multiply by its reciprocal. So 1 divided by 1/2 is the same thing as 1 times 2 over 1, which is 2. Okay, so this is equal to 2 times 1 over x, which is equal to 2 over x. And then 2 f of x plus 3, the f of x is just 1 over x, right? So 2 over 1 over x plus 3 is 2 over x plus 3. And 3 times x minus 1 in parentheses plus 2, the x minus 1 goes into the box, plus 2, so it would be 3 over x minus 1 plus 2. And that is the end of page 3 and 4.